Welcome! In this video, I will show you how to model solid Lagrangian particle deposition on a wall using a fluid film model. For some applications, for example, in battery thermal runaway, it is very important to measure the amount of solid particles accumulated on a wall. One way to account for this accumulation is to make a transition between solid particles and a fluid film at the wall. In this way, we can measure mass accumulation and estimate heat transfer between the particles and the wall. I have prepared a simple example to show how this works. It is a cubic volume where one of the boundaries is defined as wall, one as symmetry, and the rest as outlet type. To set up the Lagrangian fluid film interaction, we have to select the fluid film, Lagrangian multiphase, and multiphase interaction models. In the Lagrangian multiphase node, we set the phase as solid and select the properties of our particles. It is important to select the two-way coupling model, as this is the way we will be able to transform the particles into a film. In the fluid film model, we can't select a solid film. Therefore, we have to select a fluid film and set the density of the liquid equal to the solid particle density. We have set a very high dynamic viscosity value to stop this film from flowing. In the multiphase interaction node, one interaction needed is between the Lagrangian particles and the fluid film. We select the impingement model to enable the transformation of the particles to a film. Do not create an interaction between the film and the gas phase, as there will be no motion of the film nor splashing. After creating the shell region, we go to the Lagrangian multiphase node and expand the particle phase and boundary conditions nodes. Here we will find two nodes, one for the wall and the other for the shell region. We expand the shell region node as it is here where the fluid film will form. Expand physics conditions and select mode. In the properties window, we change the active mode to fluid film. Afterwards, we have to set up the injector for the particles and the flow conditions. In my case, there will be no external flow and the injector is a simple solid cone type. After defining the desired data analysis elements, I run the simulation and watch how the solid particles are converted to a fluid film. The high viscosity of the liquid ensures the film will not displace to other parts of the wall as the simulation progresses. Thanks for watching.